So in the last video, we talked about linear programming, which is the first family we were interested about. And now I want to define you the semi-definite programming, also called SDP, which will be the main family we will be talking about. Well, the SDP is in a way just LP, so plus semi-definite matrices that are loaded. Uh, so SDP, it's really not rigorous in a way what I'm writing, but you can understand. It's just a linear program plus quasi semi-definite constraints. So if you remember, LP was just this. Set of linear program for LP transpose X such that AX is inferior to B with B is superior to 0. So a polysemi-definite matrix is just this. For example, it can be X being a matrix and you have this symbol. It says that's polysemi-definite. And so now SDP, which is the sum of both, is just sub of X of trace of Cx. I'm just checking something for you. Yeah, it just says that all eigenvalues of the matrix are positive. So yeah, for PST, I wanted to be sure about the definition before giving it to you. And so you have this. No matter the I, with X being semi-definite. And it better, I'll try to explain you how we get from here to here. The fact is, no, this is just a particular case. In reality, like it's more like what I'm trying to say to you is that LP is included in SDP, and it is a particular case of polynomial matrices because there is no matrix, it's just vectors, you know? And so here we have C transpose of X, and we want to go there, or doing into the other sense. And so what you need to understand is that if X and C are diagonals, so basically if I have So we'll go to there to show you that this is just a particular case of this. Trace of Cx at the end is just the sum of I of Ci xi, which is C transpose X. Indeed, like C transpose X, it's just this as the end. So it's a sum. And so you can do the same for this. So it's just the sum of G of AEG, because we have the I of Fi, XG, AI transpose X, and so it's just A1 transpose, A2 transpose, until AN transpose, which is A at the end, the matrix A, multiplied by X, and so we have AX. And so as you see, that's a particular case, so trace of AX is just this, AX is inferred to be. And so yeah, here I was mistaken, but as I tell you, that's just the same with quasi-semi-definite matrices allowed. So we go from here to here, or here to this. It is, you have in more quasi-semi-definite matrices. So if you want LP, you just remove this condition and you get normal vectors without quasi-semi matrices allowed. So that's how both are linked.